can we come up with the way to interact with the brain wirelessly and completely remotely? How can we do that? We'll have to look deeper into the brain, into the way it functions. Ultimately, what we are trying to do is to control voltages on neurons. And those voltages are controlled by concentrations of ions inside and outside of neurons. If we learn to control those concentrations of ions, we can control the brain. How can we do it? Well, let's imagine a neuron as a building. This building has walls. That's a neuronal membrane. Inside those walls, there are doors. Those are ion channels. They allow for ions to go in and out, for people to go in and out. One way for us to get into that building is to have the right key to the right door. The other way to get into a building is to pull a fire alarm. That would open fire escape doors, and then ions and people can move in and out. And this is exactly what I'm proposing to do. And those fire escape doors are the familiar ones. Imagine eating a habanero. That familiar sensation of burning pain on your tongue is precisely the same if you were to place your tongue directly on the stove. And the reason for it is because the ion channel inside the receptors on your tongue that responds to capsaicin, which is the hot spice of a habanero, is exactly the same ion channel that responds to heat. And this ion channel is not only present in your tongue, or it's also present in the neurons in your brain, or across the entire nervous system. So basically, what I'm proposing to do to control the brain is to heat it up. We don't want that, that's fever. What we do want is to control specific groups of cells when we want them, and to do whatever we need them to do. How can we do that? How can we deliver that heat stimulus where we need it, deep in the brain? Remotely and wirelessly. It turns out we humans are really transparent to magnetic fields. In fact, the fields with frequencies of hundreds of kilohertz and low amplitudes, we don't feel them at all. Why am I telling you this? Because we can synthesize magnetic nanoparticles. Those are essentially speckles of magnetic dust, about 1/5000th of your hair, and they can be dissolved in water and form a fluid that looks just like an espresso. But when we place them in a magnetic field that's variable, these particles undergo a process called hysteresis. We can think about it as a magnetic analog of friction. And through that process, they heat up. So now, imagine we can inject this espresso-looking fluid of particles into the brain and then apply the field to the entire subject, and only the groups of neurons that are surrounded by the particles will experience the heat and become activated, while everything else will stay intact. Sounds hard, right? Let me show you a movie. What you're going to see is neurons flashing in response to a magnetic field stimulus. In this picture, those flashes mean activity, mean firing action potentials. There will be no wires and no tethers. We have a quiet group of cells until the stimulus comes on. And now they start to respond to the stimulus. No wires, no tethers, no brain sockets, no tissue damage. Completely remote stimulation of a precise group of neurons. So maybe, as we are starting to learn how to harness those natural fire escape mechanisms of our neurons, we can start to learn how to interface with the brain wirelessly and remotely. And maybe one day some heroic mind can pilot an avatar from the comfort of their tube.